Thank you again for joining. And today we are going to talk about Filtralite. So basically, Filtralite is a filter media. It's a trademark by Saint-Gobain. So we have today two parts that we will go through that. The first part that I will handle, it will about just give you introduction about Filtralite, the added value from using it, how we are manufacturing Filtralite, and show you some cases related to the performance of Filtralite. And then after that, I will hand the mic to my colleague Geir, who will take us through the journey of the biological treatment for Filtralite. So this will be my agenda. So I will just give you a quick introduction about myself, also give you information about Saint-Gobain, and then we will go to the Filtralite application, what kind of application that we can use Filtralite with, and then talk about the traditional filtration media, what are the challenges that we can face, and how Filtralite can overcome that, and then tell you about Filtralite manufacturing process, and then give you two cases very important about the performance of Filtralite. So starting by myself, as my colleague Christina mentioned, my name is Mohammed Kastawy. I'm originally from Egypt. I'm based in Saudi Arabia, and I hold a Bachelor of Mechanical Engineering. And now I'm just a few steps to get my Master of Business Administration from Liverpool University. I hold more than 17 years experience in the Middle East, mainly for pumps, water heaters, and solar water system. Now I'm joined Saint-Gobain in last September 2023. So now it's almost 1 year and a few months. And my focus area is expanding the Filtralite business in the Middle East and working closely with our customers, mainly our OEMs, and also with our end users and consultants. Saint-Gobain. So Saint-Gobain is a well-known company. It's started in 1665. So that's more than 360 years. The company. Of course, we had many employees. Our colleagues are working under Saint-Gobain. We are now more than 160,000 employees globally in 76 locations. Our turnover last year was 47.9 billion euros. And we are committed to the 2050 about achieving carbon neutral globally with 8 cross-business researches and development centers around the world. So Filtralite, again, is the filter media and it's trademarked by Saint-Gobain. Now about the applications. So where I can use Filtralite. Basically, the answer for this question, I'm always telling my customers that wherever there is sand filter, you can use Filtralite. So where we can find the sand filter. So starting by having this map, which will take us through all the applications. So starting by drinking water treatment, you have a drinking water treatment, you want to have this treatment and you are using the sand filter, then you can use Filtralite instead of the sand. Now, while moving to the desalination part, when you have the seawater intake and you have the screening and then you have the pre-treatment just before the membrane, again, there is a sand filter where also you can use Filtralite. And for the odor treatment as well and for the wastewater treatment. So usually when we say pure, so we are talking about some of our products, different models, different grain size, different bulk densities, and it can be used in drinking water and desalination. While when we use Filtralite air, that refers to the odor treatment. And for Filtralite clean, then we are referring to wastewater treatment. So what is the traditional filtration media? So usually we can see that mainly our customers either are using one layer, which is sand, and of course below the sand we have the media support like gravel, or we have second option where you can use different media like anthracite mainly, and below that the sand. So this picture on the left just explaining about the pressure drop when the water goes from up to below. So as you can see here, you have different pressure drops from the water throwing the sand layer, while here with the sand and anthracite. So there are some points that we are telling our customers about that. The first point about the retention. And when we say retention for the media, that means are the media that we are using now are having the capacity of retention to hold the suspended solid? So if you can see my camera here, I just take this example. If you can see my hands here, let's say that this two hands is two particles of sand or anthracite. So basically, you are using the difference or the space between these particles, right? So once these particles are clogged, then there is no filtration. Then you have to do the backwash. While with Filtralite, it's like the opposite. As you can see my hand here, you are using also the space between the particles, but you are using also the porosity of the media of Filtralite. And this is what makes Filtralite very unique because it's high porosity media. So you can use the space between the particle at the same time you can using the holes that inside the particle itself. While with the normal filtration or filter media, we can see that the filtration rate usually between 4 meter per hour up to 12 meter per hour. While with Filtralite, you can be able to increase it to reach 20. And a matter of fact, we have even some cases that it was going beyond 20 and we reach around 30 meter per hour. With the third point that you are using a head losses when it goes through the media, because again, you are using only the space between the media or between the particles. So when this one get clogged, then there's a high head losses inside your media. While with Filtralite, it gives you more longer time to have more with the retention and with the porosity. So you'll have more time till you need to stop and do the backwash. And that will refer us or take us to the expensive operation and maintenance. Because with other media, like sand, you can change sand every couple of years, let's say 3 to 4 years maximum. And with anthracite, it might take to 6 to 7 years. Of course, it depends on the water quality. But with Filtralite, we say that it can take you up to 25 years. 25 years of operation. In a matter of fact, we have even some cases that goes for more than 25 years, reach more than 30 years, and still working with the same media. The last couple of points about this red zone. As we know, the bulk density of sand is around 1,700 kilograms per cubic meter. That means if you have a volume of 1 cubic meter and you want to fill it with media, with sand, you need 1,700 kilograms of sand to fill 1 cubic meter. While with anthracite, it goes beyond 800 up to 1,000. But with Filtralite, our media start from 470 kilograms per cubic meter. That means you have a lighter media. That's how you can avoid having this intermixing. And this intermixing area, which you can see in the red zone, it happened because when you stop the backwash, and because of the high bulk density of sand and anthracite, it just dropped in your filter, and then you have this intermixing. So this area in red is actually an intermix between the top layer, like anthracite, and the bottom layer, which is sand. And of course, having this mixing between these two layers, it will lead you to have a low efficient in the water quality. And this you can avoid it by using Filtralite. So what is Filtralite? If you look to this picture, it's just, you can see it's small grains. You can just hold it by your hand and it have a different shapes. So it's not completely circle. It's not completely like a cube. It have a different, it have I would say that different shapes. So this Filtralite is actually expanded clay. So we go to the very cold countries and we dig in the ground up to 3 to 5 meters. And then we extract this clay. We take it to the factory. We do like a pre-treatment mixing. And then what is interesting in that picture that you can see whatever goes through this fern, this one is around 400, it's about 48 meter long, and it's rotating 24/7 with a temperature reach up to 1,200 Celsius. So what happened inside that this clay, it goes inside this high temperature, and with this, by controlling this temperature, you can find that all the organic material inside the Filtralite, it turned into gas and evaporate. And then you have this Filtralite, it's turned like the popcorn. So it's expand the volume and lose the weight. So as you can see here, 1 cubic meter goes inside this industrial process, it end up with 3 cubic meter. And then we crush it and saving with different grain size and different density. When we are talking about desalination part, our models of working in pure, under pure title, it hold NS and NS certificates. This picture also explaining a lot about the differentiate between Filtralite and other media. As you can see in that part, as I explained a few minutes back, that you are using only this space between the particles. So once this space are clogged, then you have the filter need to be stopped and do the backwash. And that, if you think about it, you have this depth of the media. And usually what's happened with the normal media, that the top layer is the first layer to get clogged because all the space between the particles, it's stopped to have the water goes flow. And then you are not utilizing the whole depth of the filter. While you can see in the right picture that also we are using the space between particles, but in additional to that, there are these porosity, high porosity or voids, like we call it, in the particle itself. It's totally different than sand and anthracite. With these particles, you can hold more suspended solid. You can give your filter longer lifetime till you stop and do the backwash. So you are utilizing the full depth of your media. So in terms of OpEx and CapEx, and here I know that OpEx, it might be some important for some people or customers, but for others, it's CapEx. So when we talk about OpEx, what you can expect from utilizing Filtralite. First point, you can expect 2 to 4 times less backwash. So let's say that you are doing one backwash every day. Then you can have this one backwash every couple of days up to 4 days. Of course, again, depend on the full process and depends on the water quality. At the same time, the availability of having these voids or this porosity, it gives you the higher filtration velocity. Like we said, we can reach up to 20 meters per hour because actually you are giving more space to the water to go inside. That's why you are increasing the filtration velocity. While if we consider an RO plant, this you will have with Filtralite more biological stable water. So you're avoiding this biofouling, or you will have a less biofouling in the membrane. And as we know, the stage of the membrane comes out after the filters or the sand filters. Then by having less biofouling inside the membrane, you are giving a longer lifetime to your membrane because actually you are giving more actually space to the bacteria to grow inside the media. And all of that will go in the backwash. Also, you are giving less cleaning and replacement of the cartridge. At the same time, you are giving a possibility or allowance the water to go inside with the higher suspended solid. And we are going to see that in one example. In terms of CapEx, of course, by increasing the filtration rate, you will be able to reduce your footprint. So let's say that I have this plant, which give me around 100,000 cubic meters per day, just an example. And the design, working with the consultants, he was calculating the design based on a filtration velocity that, let's say, it's like 10 meters per hour. And he brought this 10 meters per hour by utilizing this space between the particle, either it's sand or anthracite or any other media. But with Filtralite, as I said, because of this voice and porosity, you are giving more higher filtration rate. That's how you can reduce, let's say, from 10 filters that you are using now to generate 100,000 cubic meter per day, you can use less filters. You can use like 9 filters, 8 filters, I mean up to 6 filters. Of course, when you use less footprints and using less filter cells, then you are saving in your backwash pumps, you are saving more concrete, you are saving more steel, of course. The other point that, as I mentioned, because the Filtralite, it's very light media, then during the backwash, you need a lower backwash flow. Because just imagine that you need to lift up 1,700 kilograms, while with Filtralite, it can be from some models from 470 up to maybe 700 or 800 kilogram per cubic meter. Then you need a smaller backwash pumps. Also, again, the longer lifetime. So now we are seeing many, many projects in our area where the contractor is taking, or the OEM is taking the project like BOT for 20 years or 25 years. So just imagine that you have an media, you need to replace it every couple of years. So how many times you are going to replace it? What are, of course, the consequences of replacing the media? And how much time it will take? While with Filtralite, it can go up to 25 years. There is always a question come to me that, do I need to use Filtralite always with sand? And the answer, as we can see here in this slide, the answer is no. You can use Filtralite with sand, or you can use it as a single layer or multi different layers. So it doesn't necessary to have sand under the Filtralite. And this is an added value for Filtralite. Of course, we are giving like an option to our customers either to use one layer of filter light, especially if we are talking about like a depth around 1 meter maybe or 1.2 meter. While if we are going to higher depth, then you can use two different layers. With these two different layers, you can see that the top layer, it having the bigger grain size with a lower density, while the bottom layer, it has the smaller grain size with a heavier density. Then in that case, you are avoiding this matter that we have seen, the red zone, which you have this intermixing between the layers. Because once you stop the backwash, you have the heavier layer goes down, and then the lighter one goes. So you will have two different separate layers. During the backwash, again, you will have the same setup. Of course, using Filtralite, it will affect you by having low turbidity and low SDI coming as a result in desalination. So now I will just go very quickly through a Filtralite performance, and I have here two cases to show to you. Of course, we have many cases. Actually, we have supplied Filtralite to more than 750 plants over the world. Some of them are the biggest, and they are everywhere. But here I'm just considering two performance about Filtralite. The first one is coming from Ingopras Engineering Institute in Spain, where there was the measurement of having this experiment is to measure the suspended solid. So actually this one is very interesting. So what they have done, they have put Filtralite with a grain size 0.8, 1.6 plus sand 0.4, 0.8. So you have bottom layer sand and the top layer is Filtralite. And in the other hand, you have anthracite on the top with the same grain size like Filtralite here and a bottom layer of sand. What we want to see in that, we want to see if the water goes inside with 80 milligram per liter as suspended solid, how much exactly Filtralite can remove from this. So when we look to the anthracite, the first one, from this 80 milligram, it was the result from using anthracite was going from 80 milligram per liter for suspended solid only to 64.75. While if we look to the left side, we can see that it was reduced from 80 milligrams to 9.17. So we are talking about a big gap here, 64 and 9.1. And also when you look to the turbidity, you are even getting better quality of water. This one is around 12.7 NTU, while with Filtralite is 1.5. Of course, this experience done with a different velocity, so 8 meter per hour, 50 meter per hour, and 20 meter per hour. And we continue to increasing the suspended solid coming inside the water, we can see the gaps goes even bigger. So this one, 200 was reduced only to 163 with a turbidity of 35, while with Filtralite, it was reduced up to 45 with a turbidity of 7.8. The same goes for 350. This one, it's almost nothing happened. It's 350, and it was reduced only to 332 or 43 with a turbidity of 78, while with Filtralite, it was reduced from 350 to 99. And this gives you indication when I was saying in OPEX that it can give you more allowance of having more suspended solid in the water. This experiment just explaining that with this kind of retention and porosity that Filtralite has, can give you longer time to run your filter till you stop and do the backwash. The second one done by Swiss. And actually, after this meeting, you can just approach me and we can give you many cases that it has been done. And the good thing about these case studies, it's mostly done by a third party. So we are not the one who make the study, but just we give it to a third party who evaluates and give us the feedback. So this one done by Swiss. So in this case, Swiss, they have tried 5 different columns. The first one was using sand 0.75 and sand 0.95 and sand with anthracite and 1 layer of Filtralite and 2 layers with Filtralite where we called it mono-multi. What we need to achieve here, we need to see the first point, to see the turbidity, what will be effect on the turbidity for this different 5 columns, and also seeing the UFRV. And UFRV, as we know, is referring to unit filter running volume. So basically, I'm talking about how many cubic meter goes through a square meter till I need to stop and do the backwash. Of course, all of these parameters are the same for the water goes inside the column. So as we can see, the green The green color here for Filtralite is achieving the best turbidity. Even it can goes beyond less than 0.1. While with UFRV, here, as we can see, the best for the three experiments, sand 0.75 and sand 0.95 and sand and anthracite, was sand and anthracite, and they reach up to 1,250 cubic meter per square meter. And then they had to stop and do the backwash. While with one layer of Filtralite, it was reaching up to 1,750. And in that limit, they need to stop and do the backwash. Even goes better when you are using 2 layers of Filtralite. It can reach up to more than 2,500 cubic meter per square meter. And this also, again, give you an indication about how Filtralite can give you a better quality of water and how much you can save in terms of energy when you reducing the numbers of backwash.